All right, so it's a bullet being fired at 1 kilometre per second. Don't forget that's 1,000 meters per second. All right, it tells us to use x double dot is minus kv squared, so we're going to do that first. So, sorry, it tells us to use v to v dx for x double dot. So v to v dx. So we could divide through by that v. So that v is going to cancel one of those. So we have 1 on v to v, and we have a minus k dx. So we're doing, so we're doing log v. Now it's positive, so I don't have to worry about that. It's just going one direction, minus kx plus c. Now do remember we've got t equals 0, x equals 0, and velocity is 1 kilometre, so 1,000 meters per second. So we can use this to, well, let's use the v and the x first. So we've got log of 1,000 equals minus k times 0, 0, so that equals c. So if I just put that back in, I've got log v is equal to minus kx plus log 1,000. Now if I make x the subject there, so I'm going to have x equals log of 1,000, then I've got minus log v, and I'm going to divide by k. Alright, so another way to write it if we wanted to would be 1 on k. We've got log of 1,000 over v. Alright, now we need to find what k is equal to, so what else do we have to sub in? We've been told that v equals 10 when x equals 100. So let's look at that to find k. So we've got 100 is 1 on k, and log of 1,000 on 10 is 100. Alright, so our k here is equal to, now 100 is 10 squared, so we could always make it 10 and put the 2 in front. So we're going to get 2 on 100, which is 1 on 50, so it's log 10 on 50. Alright, so there's our k value. So our x value becomes, so we've got 1 on k, so I'm coming back to here, or to here, doesn't matter which one. So 1 on k, so I'm putting that k upside down, so 50 on log 10, and I'm going to have log of 1,000 minus log v. Alright, so that is the same as, okay, so remember this also, 1,000 is the same as 10 cubed. So that, if I was doing one at a time, one term at a time, I could actually put that 3 at the front. So 3 lots of 50 is 150. And then you've got log 10 on log 10, so that cancels, so it's just 150 minus, and here I can't cancel anything, so it can just be log v and log 10 there. Alright, so there's our equation that we're going to use. When the velocity equals 1, we want to find how far it's gone. Okay, so at v equals 1, we've got x equals 150 minus 50 times log 1. Log 1 is just 0. So you can see you're going to get 150 meters. Alright, so that's A. Let's have a look at B. So for B, we're looking at, let's get rid of this. Hopefully you've got that written down. Alright, so let's go back to the question here. So this time it wants us to use dv to t. So dv to t for our acceleration. So we've got minus k to t and v to the minus 2 V. All right, so we're going to get minus KT, and we're going to get minus 1 on V plus C. So again, what can we sub in? Well, we know initially the velocity is 1,000. So let's use that to sub in. So we're getting C equals 1 on V, and that will be 1 on 1,000. All right, so let's go back and also use the fact that we know T equals 1 and V equals 10. So let's go back to here. So we've got minus K times 1 equals negative 1 on 10 plus C, and C is 1,000. All right, so we're looking for K. So positive K is 1/10 minus 1,000th. Now, if we wanted to make this to have the same denominator, I'd have to times by 100 here. So I've got 100 on 10,000. Sorry, on 1,000 minus 1 on 1,000. So 100 minus 1 is 99 on 1,000. So K is going to be 99 on 1,000. All right, so let's put it back into my T equals equation. So I'm kind of using this all the time because I haven't written it, which I should have. But so T is going to be, let's think about it. So I'm going to divide by that negative K. So it's going to be 1 on K. I'm going to have negative 1 on V plus C. All right. So if I had 1 on K, it would be positive 1 on V minus C. All right, so that's what I'm going to use. So let's just go up a little bit, remembering that that's our K value now. So our K value, so it's 1 on K, so I'm tipping that K value upside down. 1 on V, and our C was 1 on 1,000. All right, so there's my T equation that I'm using, and it says when velocity equals 1, how long does that take for velocity to equal 1? So we're going to have 1,000 on 99. This will be 1 minus 1 on 1,000. All right, now remember that 1 minus 1 on 1,000 is just 999 on 1,000. So 1,000 on 99, 1 minus, right. Yeah, okay, so the 1,000s there, if I kind of look at it like this, they'll cancel, and what will be left? Well, 999 on 99, that's why it was confusing. Put that in the calculator, you get 10 and 1 on 11 seconds.